Okay, so today we're going to be going over a related rates problem. And this problem is a conical related rates problem about a boy named Johnny and how his ice cream cone is leaking. And so we have the dimensions of the cone that he bought, and I'm going to write those down right now. Okay, so here is his cone. It says there's a radius of 3 centimeters and a height of 15 centimeters. So, since this is his cone, the problem says that the cone is leaking at a rate of 2 centimeters cubed per second, and we have to find the rate of the height changing when the height is at 5 centimeters. So, let's get into it. First, we have to know the volume formula of a cone, which is V equals 1/3 pi times r squared times height. So now that we know the volume formula, we are going to try to get rid of as many variables as we can, leaving one left. So we're going to get rid of the r variable. We can do that by taking the ratio of the radius to the height. So 3 out of 15 is also known as 1/5. So you could say that r is 1/5 h. So we can rewrite this equation as v equals 1/3 pi times 1/5 h squared times h. So now that we have that written down, we can look inside the parentheses and square the terms. Since there's the 1/5 and the h inside the parentheses, we can square both of those. So v, let's rewrite it, v equals 1/3 pi times 1/25, and then the h will get squared also, but since there's going to be an h squared and another h, we can just rewrite that as h cubed. Next, we can combine the 1/25 and the 1/3 by multiplying them together. If we combine these two terms, we can rewrite the equation as v equals 1/75, since 3 times 25 is 75, pi times h cubed. After we have that written down, we can now resort to the chain rule. So for the chain rule, we can take v equals, and then bring the exponent down to the front. So v equals 3 times 1/75 pi h, and then subtract 1 from the exponent, so that would be squared. So 3 times 1/75 is the same thing as 3/75, so we just rewrite that real quick. V equals 3/75 pi h squared. Now we can take the derivative of the v and the h variables. At the front, we will put dv/dt as the derivative of v equals 3/75 pi h squared. Now we'll do the derivative of h, which is dh/dt, so let's write that down. Now we can plug in the height for h, so dv/dt equals 3/75 pi, and then the height is going to be 5, because it tells us in the problem, find the rate of the ice cream when the height is 5 centimeters inside the cone. So 5 squared dh dt. We can rewrite the equation in simplified terms. So this would be dv/dt equals 1/25 pi times 25 times dh/dt. So let's do that. dv/dt equals 1/25. And you know what? Since 25 times 1/25 is just 1, we can completely cancel that out. So dv/dt equals pi dh/dt. So, since dv/dt equals pi times dh/dt, we can now plug in the rate at the velocity as the velocity is changing. So the rate of the velocity changing is 2 centimeters cubed per second, as we were told in the problem, equals pi times dh over dt. since we're trying to find the rate at which the height is changing as it moves down the cone, as the ice cream leaks out, we will divide dH over dt by pi and do the same thing with the other side so we can get dH over dt by itself. So divide by pi and divide by pi. Now the equation becomes 2 centimeters over pi per second. Notice there's not a cubed anymore in the equation because we are finding the change in the height, not the change in the volume. 2 centimeters over pi per second equals dH over dt. So since the ice cream is leaking out and going down the cone, the answer is going to be negative. Negative 2 centimeters over pi per second equals dH over dt. Now you have found the rate at which the height is changing when ice cream is leaking out of Johnny's ice cream cone. Alright, I'm done with this. Please tell me that was 9 minutes. Please tell me that was 9 minutes. Let's go, baby!